Okay, so we're going to solve absolute value inequalities now. And it turns out solving an absolute value inequality is really just solving a compound inequality. And we just have to determine which compound inequality it corresponds to. So if you remember that absolute value is sort of the distance, how far away you are from a particular point. So when we talk about the absolute value being less than c, really what we mean is that ax plus b is squished between c and negative c. If we want the absolute value to be bigger than c, then that means on the number line, we have c and we have negative c, and we want the stuff out here. So we want ax plus b to be smaller than negative c, or ax plus b to be bigger than positive c. Whereas in this one, we wanted all the stuff squished between negative c and c. So if you remember, we did these compound inequalities, we solved both types. So when you're solving an absolute value inequality, the first step, the one you want to think about first, is isolate the absolute value. You can't use these properties until the absolute value is all by itself. All of our inequality solving rules still hold. When we multiply or divide by a negative number, we have to flip the inequality. So let's start with example number 1. Negative 2, absolute value, x minus 4, that's the part we want to get all by itself, is less than or equal to negative 6. So I'm going to start by dividing everything by negative 2. When you divide by a negative, you have to flip. So this is going to be absolute value, x minus 4, greater than or equal to positive 3. That's type number 2. So we're going to break this into 2 inequalities. The first one is going to say x minus 4 is less than or equal to negative 3. The second one is going to say x minus 4 is greater than or equal to 3. I used this rule number 2 here to break it up. And remember, when I'm solving this kind of compound inequality, I just solve them separately. So I'm going to start by adding 4 to both sides. X less than or equal to 1. I'm going to do the same thing to this other inequality. Add 4 to both sides. X greater than or equal to 7. So on my number line, I have 1 and I have 7. I want x to be less than or equal to 1. I'm going to put a filled in circle there because I have that equals. Or greater than or equal to 7. Again, another filled in circle because I have that equals. So remember, when you get 2 intervals, you put that u in between them. I want negative infinity to 1 with a bracket because I have that filled in circle. And then 7 to infinity. Remember, infinities and negative infinities always get parentheses. Okay, let's try again. So the first step is isolate this absolute value. So I want to start by trying to get that absolute value part all by itself. So I'm going to subtract 20 from both sides. That gives me negative 3, absolute value 5x minus 2, greater than or equal to negative 39. I'm going to divide both sides by negative 3. When I divide by a negative, I do the flipping. So I have absolute value 5x minus 2 less than or equal to 13. Less than or equal to is that rule number 1. I break it into the 2 where I squish it in between. So I want to squish 5x minus 2 in between 13 and negative 13. I solve this by getting the x all by itself, but I have a compound inequality, so I'm going to add to a bunch of places. So negative 13 plus 2 makes negative 11, less than or equal to 5x, less than or equal to 15. Divide by 5, and I end up with negative 11 over 5, less than or equal to x, less than or equal to 3. So on my number line, I get negative 11 over 5. I get 3. I want all the pieces in the middle. I'm going to use filled in circles because they both have equals on them. So when I write my solution in interval notation, I start at negative 11 over 5. I end at 3. They get brackets because they had filled in circles.